Hey there, I'm Joe Weems. Before we get into the video, I want to remind you about ng-conf 2023 happening in Salt Lake City, Utah on June 14th and 15th. Head over to ng-conf.org to check out the speakers, check out the talks, and to get your ticket before they all sell out. We'll see you there.
Hi there. Today I'm going to be talking about a topic that I think most of us are not very familiar with. I'm going to be talking about Site Reliability Engineering, or SRE. Okay, I know what you're thinking. Brian, this is an Angular conference. Why are you up here about to give a talk on site reliability? That's a back-end problem. And you know what? I think you're right. It is a back-end problem. Like you, I'm a front-end UI engineer. I'm an Angular developer. To learn more about the topic of site reliability, I went out and bought the book. Yeah, this hefty 500-pager that compiles the knowledge and faithful stories of the apostles of SRE at Google. While I think it's a valuable read, the more I read, the more it confirmed to me that site reliability is not necessarily a back-end problem. Fundamentally, it's a user experience problem. Why? If a service or API is unstable, worse, stable and degrading, the UI is going to be the first to know. Before I go any further, let me introduce myself. My name is Brian Love, and I'm a UI engineer, and I'm intrigued by site reliability engineering. After reading the book, I spent several weeks talking to and interviewing people about site reliability. I interviewed directors, leaders, architects, engineers, all across the spectrum from small, medium, and large organizations, many of which you probably know and maybe even use some of their services. In general, I found that most organizations fall into three groups. First, some organizations have no focus or knowledge of site reliability. Frankly, they just don't have the resources or requirement to do so. Simply put, they just shrugged at site reliability. Second, I found that there are a few select organizations that have gone through site reliability hell. They struggled for months, even years, to build a culture of reliability in their organizations. They learned through trial and error, and they've built systems and procedures to ensure the reliability of their applications. Third, I learned that many organizations are stuck in an endless loop of triaging and pushing hotfixes. They are acutely aware of their need for site reliability. Shockingly, many of these organizations sign what are called service-level agreements with their customers. I don't know if you know what that is, but a service-level agreement, it's a legal binding contract that guarantees a level of availability of their service. Perhaps even scarier, many of these organizations, they don't actually even monitor or even measure the reliability that they're legally bound to provide. I came across the conclusion that most of these organizations rely on a strategy of hope. But the reality is, hope is not a strategy. Oh yeah, I stole that quote right from this book. I like it. I think it captures the essence of site reliability at most organizations where hope actually is the strategy. Let me start by dispelling 5 myths of site reliability. First, it's common to believe that the metrics that are required for measuring reliability can be gathered on the back end through things like server logs. But not all behaviors can be collected on the back end. A few examples include things like latency, maybe degrading API performance, or core web vitals. Second, user experience is perceived to be aligned with the performance of the back end. That's just simply not true. We know as UI engineers that UX includes things like runtime performance, runtime exceptions, and more. Third, the reliability of a system perhaps can be measured as uptime versus unplanned downtime. However, today, with distributed systems and distributed users, time-based availability may not accurately capture the true availability of a system. Rather, I think reliability should be measured as a percentage of successful requests. This is a more accurate representation of the user experience and can be used to determine the success rate of our applications. Fourth, our noble goal is to build 100% reliable systems. No. Simply put, 100% reliability is just stupid. The greater the reliability target of a service, the greater the cost to engineer that service. Beyond a certain threshold, there are diminishing returns for the increased reliability of a system. Fifth, the pace of innovation should not inhibit the reliability of a system. This too is incorrect. Innovation is at odds with reliability. The reality is, we know this, to move fast, we may, and often do, break things. We have to work with stakeholders to strike a balance between innovation and stability. So what do? We need to embrace risk. We're constantly pushing new features and building better products. While embracing risk, we also must have the observability into the availability of the systems that we are building. And we're going to do that with 3 strategies. 1, we need to define the availability of our systems. 2, we need to build a culture of reliability through measuring and monitoring the reliability of those systems. And 3, we have to plan for failure. Okay, let's dive in. Let's talk about those. Let's talk about how we define the availability of our services. You might want to ask yourself some of these questions. What level of availability do our users expect? Does availability strongly correlate to revenue? Maybe what level of availability do our competitors provide? Is the service customer-facing or enterprise-facing? So let's look at how we define availability. If we determine that the level of reliability that is required for our system is extremely high, let's say 5 nines, then our system should only experience 5.5 minutes of downtime per year. We need to balance revenue or perhaps reputation with the cost to achieve a certain level of availability. Costs not only include engineering time, but also the redundancy of our systems and opportunity costs. Let's talk about an example here. So in this example, I've got an application that's generating $1 million in annual revenue, and we're already achieving 3 nines of availability. Okay, so that's 99.9%. Then, to increase to 4 nines provides $900 in value. If the cost is less than $900, then we should invest in increasing the reliability of our system. Next, we need to build a culture of reliability in our organizations. We do that by first identifying what are called service level indicators, or metrics that reflect on the reliability of our applications. Next, we establish what are called service level objectives, which are targets that are based on our SLIs. And finally, if necessary, we need to establish service level agreements. Okay, first let's talk about SLIs. SLIs are carefully defined quantitative measurements of some aspect of level of the service that is being provided. Some examples include things like failure rate, latency, maybe largest contentful pain, first input delay, or cumulative layout shift. To make an indicator valuable, we often need to aggregate these values over a time interval, and then we need to identify the frequency of measurement and potentially filter that indicator based on things like service, geography, or maybe even region. Let's look at an example SLI. Here, we're going to measure the mean failure rate of requests over 60 seconds. We're going to take that measurement every 10 seconds, and we're going to filter requests to the US West 2 region. But you might be wondering, okay, Brian, this sounds great. I like the idea that you have here. I appreciate you kind of communicating this. But how do we actually do this? I'm an Angular developer. How do I measure this? Well, what we can do is we can instrument our Angular applications to collect metrics for our defined SLIs. In these examples, I'm going to be using ng-conf. ng-conf is well suited for this since we can listen to multiple actions or events that are occurring in our applications. When a successful event or perhaps unsuccessful event occurs, we can log that event to an external system. We can use something like Datadog if we'd like. Let's take a look at another example of an SLI. In this example, we're going to be measuring the median LCP over 5 days. And it's going to be measured on the initial load of the application. And we're going to filter for users with an effective 4G connection. Again, we can use ng-conf for this. We'll use the performance observer to measure the largest contentful paint. And we'll send that data from our front end to an external source. Okay, now that we've learned about service level indicators, let's talk about service level objectives, or SLOs. Service level objectives are established by stakeholders of the system, and they're going to help us to determine the internal reliability of our system on a quarterly basis. The stakeholders are responsible for monitoring these SLOs to ensure that the team is meeting these objectives, and if necessary, to take corrective action before it's too late. Service level agreements, or SLAs, like I mentioned earlier, are legal contracts between your organization and your customers. It's important to note that your internal SLOs should have a greater reliability target than your SLAs. And why do we want to do that? Well, basically, we want to underpromise and overdeliver. But also, this gives us a buffer for when the reliability target of our system is quickly approaching the upper bounds of that SLO. And finally, we need to plan for failure. We plan through failure through things like error budgets and having a post-mortem culture. Let's talk about error budgets. The main benefit of an error budget is that it provides a common incentive that allows both product development and reliability engineers to strike the right balance between innovation and reliability. We're going to define quarterly error budgets based on our SLOs, and we're going to continue to innovate and build features while we have surplus in the budget. As the error budget is spent, we may need to shift our engineering resources from feature development and innovation towards site reliability. In this example, we've got an error budget, and this is like a burn down chart you might see in something like Jira, and you can see that it indicates that we have a surplus. However, in this example, we can see that the error budget has been quickly spent in Sprint 4. We've got little room left for future development. Tracking an error budget enables us to prioritize reliability when necessary to meet our quarterly SLOs. The reality is, incidents and outages, well, they're inevitable. But we need to have a post-mortem culture to ensure that we reduce incidents from occurring and that we learn as a team. Now, every post-mortem culture might look a little bit different, but I think it generally includes things like documenting the incident, understanding the root cause, and putting into place effective preventative measures. So the question I have for you today is, what type of culture do you see yourself in? Perhaps you're at an organization that you just don't care about reliability. Heck, maybe you don't even need to, and that's fine. Or perhaps you're currently going through the process of building a culture of reliability at your organization. My guess is many of us find ourselves stuck in an endless loop of triaging and hotfixes. So here are my key takeaways. First, we have to embrace risk, but we also need to balance innovation with reliability. To do that, we need to define the availability of our systems. We need to start building a culture of reliability in our organizations. And finally, we need to plan for failure. Because remember, hope is not a strategy. Thank you very much.